Hello. You are audible.
Okay, sir. Sir, our participants are joining. So
problem.
we will, okay, we will start within
No
2 minutes.
problem.
Okay, sir.
Okay, we will start after 5 minutes. No problem.
Okay, sir. Okay, sir.
I'm
Thank you.
just keeping my microphone and camera just off.
Okay,
But
sir.
I am here online in my office.
Okay.
Okay.
Sir, in starting, please switch on your camera for only 5 minutes. Take a screenshot.
No. I
Can
will
you-
keep it. I will keep it camera on. Else only there is some bandwidth problem. Otherwise, I will keep it on.
Okay, sir. Hello, am I audible?
Yes.
Okay, let's start our final session of the day. Good afternoon, everyone. Welcome to our final session of the day. For our last session, we have the honor to have Dr. PG Agnihotri sir. Today's our topic of presentation is fundamentals of GIS and remote sensing and its application in civil engineering. I welcome our respected expert on behalf of TAPI Diploma Engineering College, Surat. Sir is presently working as a professor in civil engineering, SVNIT, Surat. Sir is also working as professor in charge in training and placement. Sir is having experience of 29 years in teaching, research, consultancy work, and various type of administrative work. Sir has completed his BE and ME in Water Resources Engineering from South Gujarat University, Surat, and PhD from SVNIT, Surat. Sir has guided 2 PhD students and 9 students are ongoing. Sir has researched on development of urban storm water management model and transportation planning. Sir has published 20 papers in international journal and 15 papers in international conference. Sir is associated with many professional bodies. Now, I request to all the participants to keep your mic and camera off during the session. If you have any questions, please type into the chat box. Now, without any further ado, I would like to give my warm welcome to Dr. Agnihotri sir. And sir, please continue the session.
Thank you, Professor Pragna, for your kind words. Just I am sharing the screen,
Yes,
and
sir.
I will start with the lecture. Pragna, able to see the
Yes, sir.
PPT?
Yes, sir. Yes, sir.
So let me keep it in that presentation. Okay.
Yes, sir. Your presentation is visible.
Transportation, structure, soil, urban planning, and construction management. And then also there are different sub branches are there. Anyway, but here the one important thing that is, if we can say that the subject of
Hello. Hello, sir. Am I audible? Hello. Hello.
Yeah, ma'am, you are audible.
Agnihotri sir. Hello. Mm,
hello, am I audible?
yes, sir. You are audible now.
Okay. So here this is what we can say the GIS and the remote sensing, that is a one tool. Say if you will go in a surveying and then surveying, there is a
Hello, sir. Hello, sir. Your voice is not audible. Hello. Hello.
hello.
Sir, your voice is getting cut.
Okay,
Uh,
just wait.
Okay.
Hello. Now is it coming?
Yes.
Hello.
Yes, sir. Yes, sir.
Okay. So I think there is micro microphone is away from me. Anyway, so this GIS and remote sensing. ઓકે ઓકે તો પછી એક મિનિટ હું સ્ટોપ શેરિંગ કરીને પાછું કરું છું. હા એક મિનિટ. હા હેલો હેલો
જી સર.
હા અવાજ હવે આવે છે?
સર અવાજ આવે છે બટ
હા.
સ્ટીક થઈ જાય છે વચ્ચે
પણ ના
અચાનક જ
ના, મેં શેરિંગ હમણાં બંધ કર્યું. હવે આવે છે કન્ટિન્યુઅસ?
હા આવે છે પણ જ્યારે તમે ચાલુ કરશો ને સર તો અચાનક બંધ થઈ જશે. હેલો. હેલો.
હેલો હેલો હા હવે હવે આવે છે? હેલો ઓહો એક જ મિનિટ. હા એક મિનિટ શેરિંગ કરું છું. શેર થયેલું જ હતું. હા હવે હવે વોઇસ હવે આવે છે? એક જ મિનિટ હું ફોન કટ કરી દઉં છું અને બોલું છું. હા અચ્છા એક મિનિટ. હા હા મેં પહેલે જોયું. હા ઓકે હલો હવે. હા ઓકે ઓકે હા ફોન ચાલુ રાખું છું. એટલે હું મારો ફોન છે ને સ્પીકર પર રાખ્યો છે. એટલે ધારો કે કટ થાય તો કહેજે. ઓકે okay hello. So sorry, there is just this problem of net anyway, so we will just start with our sorry, we will start with our the topic GIS and remote sensing, which is the one part. Okay, it is the part of a one geospatial techniques tool. Okay, what is this actually? The tool geo means and spatial means it is related with the space x, y, and z. So where any event happening on the earth surface, if we want to analyze that. hello હવે પ્રજ્ઞા હવે આવે છે? તો ઓકે તો વિડિયો ઓકે. So I am just keeping my video close. Okay, and now I am also disconnecting our this call also. So that is a term used for any event happening on the earth. On the earth means inside earth, on the earth and above the earth means in atmosphere. So whether it may be the some air pollution or any other aeronautical problems, if it is the problem of vegetation, flood, river, groundwater, mineralogy, so all these data set or all these events are analyzed, and if there is some query is there, it is solved using these techniques. So geospatial technology has a multidisciplinary application in civil engineering, and in civil engineering also the different branch which I told you: water resources, environment, and so on.
હેલો.
information system. Hello.
જી સર, અવાજ જતો રહી છે.
Okay. Your internet connection is unstable. That message was there here.
યસ, ધેટ્સ વાય સર.
One minute. I don't know what is the problem exactly because here we have very high bandwidth.
સર,
but,
એકચ્યુઅલી ગઈકાલે મેમના નમ્રતા મેમનું ચાલતું હતું ત્યારે બી સેમ પ્રોબ્લેમ ઇસ્યુ આવેલો આ.
uh, okay, just I think અચ્છા ચેતન સર નો માં આવેલો પ્રોબ્લેમ
ના, એમનામાં નથી
તો
આવ્યો.
એણે છે ને
આજે
હા આજે બીજું
આજે માનેકર સરનું હતું અને યસ સર, માનેકર સરનું હતું અને કાલે નમ્રતા મેમનું હતું. બંનેમાં એ સેમ પ્રોબ્લેમ આવેલો. એટલે આઈ થિંક એસબીએનઆઈટી નું નેટ છે કે પછી એ નહીં ખ્યાલ આવ્યો. હેલો. હેલો. અવાજ આવે? હેલો સર.
yes just 1 minute. હેલો.
જી સર.
હું છે ને
સર, તમારું મોબાઈલ નું નેટ એવું હોય તો કનેક્ટ કરી દો.
હું એ જ કરું છું. હું છે ને જો
ઓકે
હું
ઓકે.
વોડાફોન નું જ લઉં
હા.
છું અને યુએસબી ટીથરિંગ કરી દઉં છું.
હા, વાંધો નહીં
એટલે
સર,
શું છે કે
ચાલશે.
પેલું એમાં વાંધો નહીં આવે.
હા.
Hello, hello, hello.
Yes, sir. Yes, sir.
હવે આવે છે?
હા, આવે છે, sir.
Okay, so now I'm just sharing the PPT. Okay, now is it visible PPT and
Yes, sir. Yes, sir.
volume?
It's visible and
Both
audible
is
too.
there. Okay. Because now I have just used the mobile tethering and Vodafone.
Okay,
So
sir.
anyway, friends, now just we are starting that three tools: remote sensing, geographical information system, and global processing. We are normally known as the GIS, GPS, and RS. We will talk about two: remote sensing and GIS. So what is that fundamental? And then one just small exercise or just introduction of the software ArcGIS, that how to work with this. So here remote sensing is nothing but that is, we can say, the remote, very far, from very far, how to take the data without being physical contact, without being measurement. Okay, so that is remote sensing. So just like a remote, we have a TV remote or remote controls, then remote how to sense it, and we have to take the measurement, that is about environment, about earth surface, about any event phenomenon going on earth surface. That is the GIS is nothing but that is a geographical information system, is a computer based mapping tool. Okay, this is computer based mapping tool which can handle the large number of data. Okay, and that maybe this, there must be the data, spatial data and spatial data or attribute data. We will just see in the coming slides. So large number of data, their collection, storage, retrieval, manipulation, and presentation. And if there is some query is there, that can also be solved in a set terms of seconds or minutes, depends on the how large is your data. So GIS, the one basic requirement is nothing but it is a data collection must be very accurate and sound. If there is a little or small error remains in the data collection or in data bank, then your results may vary. So this is the things, or it is the tool, or it is a one group or family of 5 members. Just we will see, there is a GIS. This is a one actually computer based mapping tool. And global positioning system is nothing but it is a Nostar GPS, that is a navigation satellite timing and ranging global positioning system. It is satellite based radio navigation system, and it will give us the precise position of any location, any point, X, Y, and Z, but we can say in terms of latitude, longitude, and third one is Z, RL, but it is not the RL which we are using from mains 11. It is little bit different. Okay, there is a geoid and spheroid. Okay, there are two things, geoid and spheroid. We are not talking of that, but here spheroidal base is there and geoid base is a mains 11. So GPS we are not talking about the much more of the GPS. So what is remote sensing and what is GIS? Because normally all the three are also coming together. So remote sensing is, we have, there is a definition itself without being contact with the field or surface. So in surveying, if you want to measure the length, there is a contact of tap with the ground. If tap is not there, then we have a tachymetry where we are putting one instruments on the ground and another one, that is the leveling staff, at our second another point. If it is total station, then we are putting the total station on the ground, and at the point B, another point, we are keeping the prism. Okay. So there are contact, but this is a contactless. How? So that works on the energy propagation and energy platform. That is the sun's energy, and different energies are there. That we will see what is this energy propagation, okay, and how that is being done, and what are the different types that we will see. So very first, this energy, that is nothing but it is the electromagnetic energy, EMR, electromagnetic radiation. So two fields, electric and magnetic, 90-degree at each other, they are traveling together, and they have a different types of energy it contains. So using this energy platform, data is acquired. Who will acquire data? Who will take measurement? There are the sensors placed in a satellite. There are the different sensors for different types of energy, okay, which is placed there. Now, second one is a processing. So satellite, different sensors are there, and they are tracking or abstracting, or they are just collecting the energy. So actually these energies are reflected from the surface of the earth, and their energy patterns are recorded by the sensor, and then it is done, that is a processing. So this energy conversion process is done in a form of some photograph, some pictorial view, that is known as image. So satellite will take, just simple way say, satellite is taking photograph, and that photograph is converted into image. Then their analysis, quantitative, qualitative, okay, that we will identify, rectify the features on the ground using that image, and we will do the measurement, like what is the height of tower, width of river, or length of football ground or cricket pitch, that we can take the measurement. Accuracy assessment, radiometric and geometric corrections are done, and the information is given to the user, like we are taking the image from ISRO, image from USGS, free downloaded is also there, Bhuvan is also there, but if you want more resolution image, we have to purchase it, okay. So that is a basic process here. Before that, let me have this thing. Actually, I want to take you first. Yes, this thing, electromagnetic radiation. Actually, what the first thing we have seen is data acquisition. Okay. Uh, I think Aditya Chauhan wants to say something, please. Aditya Chaturvedi. Anyway, Aditya, you have raised your hand, and here there is a message. Aditya has raised the hand. So Aditya, you want to say something, please? You can write in chat box. Okay, no problem. You can write in chat box. So elements of data acquisition. So that is the, what is the energy source, okay, and how this electromagnetic radiation takes place. So which I told you is nothing but there is a two field, electrical and magnetic, and both are at 90-degree, and they are just traveling in this way, sinusoidal way, and this energy. Now this is, we are not going into the physics, but wavelength, amplitude, velocity, frequency, which is there, and it follows the law of physics, the velocity of light and other things are there. Here, let me remind you that we are just like a driver, okay. We are not doing or manufacturing the car or bike, but just we are driving the car and bike. So here the basic this thing we are not going into detail because this is not required, but we have must have some little knowledge that what is the wavelength, lambda, velocity, frequency. Okay, but frequency that we have to understand, and these are the what I can say formula of and what is the energy quantum and that is okay. We have to concentrate here EM spectrum. So this is we will just come back to our things that electromagnetic spectrum. Okay, so sorry. So electromagnetic radiation, it is nothing but it is a fundamental properties and behaves in a way, okay, and basic wave theory that is given by the physics. And there are two fields, electrical and magnetic field. And both the fields travel at 90 degrees with each other and travel at the speed of the light. And this theory is very much important for understanding the remote sensing. Okay, so why? Just we are coming to that part. So here, this is electromagnetic spectrum. Now, the energy, mainly there is a sun's energy, okay, which comes into the surface of earth and it is reflected back. Now, this energy has a so many components. Our eye or the human being is able to perceive only this energy. So energy has a very wide range of wavelength, but that wavelength of 0.4 micrometer to 0.5, 0.5 to 0.6, 0.6 to 0.7. So 0.4 micrometer to 0.7 micrometer range, any energy is having that wavelength, we are able to perceive, we are able to see. That is the human eye can see. And that is the RGB, red, green, and blue energy that we are able to see. So all the things, okay, we are able to see that has a reflected energy with this wavelength. Okay, that is the. So if suppose assume that during the night, no light, nothing is there, just assume that era of what back of 100 years, not 100, 500 years back. Okay, we have that muscle and other things. So during the night we are not able to see, but during the daytime we are able to see because of that light, sunlight, and sunlight is reflected from this, and that energy our eye perceives. But there is one thing, the God has given that is a gift, natural gift to the animals. Animal eyes during the night time when you are driving, particularly the vehicles, or you are traveling, and if there is some cow or dog or any other such type of animal, if you will see their eye, you will get something reflection or some blinking because their eye itself emits some energy. So during night they can see. Same way, sun's energy and surface of earth, vegetation, water body, and different cover, they can emit also and they can reflect also. Okay, so this is the energy. Now, what are the different energy? Ultraviolet energy, X-ray, gamma, infrared. This is known as visible band. Infrared, mid-infrared, near-infrared, microwave, radio wave, and like this different energies are. So using the different energies, mainly infrared and microwave. So that energy is also reflected from the object, but we are not able to see. Our normal camera is also not able to perceive. So the spatial sensor will track this energy, and we can get much more detail about the event about the Earth. And that is known as a satellite imagery, where there are multispectral sensors are also there. This is a spectral band, EM spectrum. These are the spectral band. So visible, visible, infrared, and microwave. These three are normally used in remote sensing. Infrared is used in total station theory, also in total station. Also, EDM is the electronic distance measuring principle. So just we are going just back, and quickly we will come back to our main part of the thing. That okay, this you have seen basic process. Now stages of remote sensing. Okay, so what are the, just 1 minute, that is a stages. So emission of electromagnetic radiation. Okay, so emission means either sun's energy, it is, that is the main source, and either self emission means water body, that vegetation, that road surface. Okay, it may emit the energy, may not emit. Okay, so self emission is also there. Transmission of energy from one source to another source. So when energy is coming into the from the sun, it may be absorbed by the atmosphere, it may be absorbed by the surface, and there is a scattering is also there. Okay, so interaction of energy with atmosphere, earth surface, absorption, scattering, and reflection, all these processes are there. But the satellite, the sensors placed in the satellite will track only the reflected energy. What are the absorbed energy, scattered energy, that has gone. But reflected energy or self-emitted energy, so that is tracked by the sensors placed in the satellite, and that energy may not be only visible, but mainly infrared, microwave, visible combination of this. So that will take, and we are able to see the details which our human eye is not able to see, that what is inside the ground, whether there is some aquifer or something. So that can be given by the image, and that energy pattern is recorded, and then it is converted into the image. So now that energy pattern, and there is a binary numbers are there, and two squares and resolutions are there, that is an entire different thing. Means we are not going to that portion. Okay, so this is the sun's energy which is coming here. Okay, and that is going back to the sensor, and here self-emitted energy is also there, and this is the satellite. Their sensors are tracking the energy, and that is converted and transferred to our PC, computer engineer, IT engineer. They are converting this energy pattern into the map, visible form, image form, and this is the image which we are using. Our work starts from here. Our means civil engineer works. Okay, so this is the product, and same thing, this is incoming ray, outgoing ray, reflected ray. Okay, which is given here from the building, vegetation, water body, and so many things are there. During its travel in atmosphere or while going back to satellite also, there is a disturbance is there, and these are the processes are there, that is energy source or illumination, radiation, and the atmosphere, interaction with the target, that is target means maybe river, maybe railway track, maybe some hill. Recording of this energy by the sensor. Okay, transmission, reception, and processing. So this is after recording the energy in the sensor, there is a transmission, reception, and processing is taken place, and then it is converted into the image form, pictorial form, and interpretation and analysis. Now from here F, our work starts. Our means civil engineer. These all are also engineer, IT engineer, computer engineer, electronics engineer. Okay, and then application means we are applying that here. This is the location where you can put the bridge or construct the bridge and like that. So now this thing also we have the scene that there is an interaction with atmosphere, scattering, absorbing. Okay, when it touches the ground, also there is a absorption, scattering, and reflection. So these are the energy interaction with the earth surface and atmosphere. Okay, so this is the physics, this is the q, that is quantum and Planck's constant, okay, that we are not touching here. So this is just the enlarged view of EM spectrum, okay, blue, green, and red. Bands are there. So this is the visible band, infrared band, thermal, infrared also there are three band: thermal, mid, and near, and microwave. So this energy is normally used in remote sensing processes. Okay, so three important spectral bands: visible, infrared, and microwave. Okay, this is for the remote sensing. These three bands, these three energy coming into this domain is important. These two human eye cannot recognize, cannot sense. Okay, at present also there is so many energy touching our body, but our body, human body, and human eye is not able to sense that, except visible. These are the application that which items are pertaining in which domain, which branch. Now, four fundamental properties of what I can say, the four fundamental resolutions. Okay, that is resolutions means we can say when now you are purchasing the mobile and you say what is the camera resolution. Okay, so same thing here, but here we have to understand this thing technically: radiometric, spectral, spatial, and temporal. Okay, so these are the energy, sorry, that is the final product sharpness, or how the final product looks, and you are able to see, or you are able to extract the higher or accurate data. So we will see just one by one this resolution: radiometric and spectral resolution. So that image that depends on the wavelength response of the sensing instrument, okay, and emission of reflection spectra of the target. So spectral means you can say band 1, band 2, okay, least 3 image, least 4 image, Landsat 1, Landsat 2, and like that. So how your image, here there is a example is there, just you can have that. This is a radiometric resolution. So here 8-bit image, 4-bit image, 1-bit image. So you can see the resolution or sharpness of the picture. So that is nothing radiometric resolutions. Okay, so spectral response are here, that whether this is having only the black and white image. But if you will use this, so here there is one more band width added. This is the spectral resolution. Spectral means electromagnetic spectrums, how many bands are added there. Okay, so least 3 is a black and white image. I am just talking about the time of 2006 to 10. Okay, I have used least 3 and least 4. So least 3 image is having more spatial, very good spatial resolution. but LIS 4 have a good spectral resolution. So the combined of LIS 3 and LIS 4 image I have used. We are not touching going to that portion at present. Okay, so this is the spectral resolution. Spatial resolution, that depends on the size of the object. Okay, space, say if you make a cell pixel picture element that size 1 centimeter by 1 centimeter, 5 by 5, 10 by 10, or 100 by 100. Okay, we are seeing 30-meter resolution image, 100-meter resolution image. So that from how much actually it is taken from satellite, but whether it is 30-meter means it looks as if you are looking the ground for 30-meter above height, or 1-meter resolution you are looking the ground from 1 meter above height, or you are looking the ground for 100-meter above height. That is spatial. Temporal is nothing, but it is with respect to time. You obtain the image of an area at 2001, 2011, 2021. So there will be the changes will be there. Okay, because of urbanization and so many things. Okay, say in 1990, I was the students of SVR CET. At that time, wherever I am sitting at present in my office, so that hydraulic laboratory and center of excellence was not there. So 1990 and this 2021, 30 years, so many lots of change in the infrastructure of SVNIT campus. Of course, the SVNIT boundary is also that is cut by the corporation. That is the rules or rules, regulations, bylaws. So this is the things. So with respect to time, whatever the changes are there, that is temporal resolution. Just we have the idea of this thing. This is a size of pixel, and we have 256 value, 0, 1, 2, 3, 4, 0 value we are assigning to the darkest portion, and 255 we are assigning to brightest portion. Okay, or in normal terms we can say it is a black and white. This is the spatial resolution, 320 by 320, 80 by 80, 40 by 40. Okay, this is same thing as if I told you that if we take the photograph from 30 meter, 20 meter, 10 meter, and 1 meter, so how it looks. And this is the temporal, particular place is there, Atlanta. So in 1973 it looks like this, but in 1987 here there is a reddish portion which has increased. This blue portion is a water. Of course, identification of an image interpretation is also one different interesting topic is there. So this is the temporal resolution. So with this, here just we are ending for remote sensing. So remote sensing is such a branch or such a tool which develop the image or which extract the data of the atmosphere, earth surface inside the earth using the different energy sensors, energy platform, and convert it into the visible form which is known as image, and we are using that image for our research work or for our whatever the purpose. That is a remote sensing. Okay, just now basic fundamentals of remote sensing, which works on the basis of theory of energy propagation, electromagnetic radiation. Okay, so now this image you have purchased the image from ISRO, Bhuvan, USGS, or you have freely downloaded. Free images are also available. Okay, but now if you want to see this image, of course, say image is also there in hard form also. You have a hard form, and if you will see, and if the same image if we'll put in a computer, I mean if you will scan it, or suppose image image itself is developed in a digital form. It is in a soft copy which is there with you, and if you will open it, normally that image will not be open in a normal Windows or Microsoft Office. If we want to study or if we want to open the image and measure something, we have to open it in some special software. That is nothing but it is a GIS software. Plus, there are remote sensing software are also there. ADAS image processing software, but this is not required at present at this level. So to see and study the image and to make some interpretation and to make some measurement, we require computer software, some another technique. Okay, and that is nothing but it is a geographical information system. Now initially we have seen that it is a computer based mapping tool, and it collects the large number of data. It stores, retrieves, manipulate, rearrange, okay, and it can be used by the users also. But only the thing is there, the data collection and preparation of data bank is a very time consuming. Suppose say if I have the data of SVNIT in terms of the number of students, number of faculties, number of branch, number of laboratory, area of campus, female students, male students, PG students, UG students, PhD scholar, hostel, so many data which I have collected and I have placed. This is called database management system. Then after I have all the data, but then after what I want that I want the list or the name of the students, those who are having only from the mechanical branch. Then I will get that data of mechanical students. Then I require that only I want final year students. Then I put my query, I can have the final year students data. In final year also, I will put that there must be the CGPA higher than 7. Then that data is there. Then I can have the different types of query. You can put only female candidate, only male candidate, or the candidates, those who are coming from only northeast side, Assam, Meghalaya. So like that, you can put your query and GIS will solve you and it will give you the answer. But the things initially I have to put in a GIS software, in a GIS platform, all the data of students with their age, birth date, height, CGPA, their hometown, address, roll number, branch, birth date, that everything I have to collect for the 1,000 students, for the 5,000 students. Okay, so that is a very big and large data is there. Now, as I told you, there is a 5 members of a GIS technique. Before that, let me have some definition. That is, there are number of definitions are there for GIS, but there are few definitions I downloaded and I explained. Very first important is the academic definition, which will give you the clear-cut idea. It is the system of hardware, software, data, people, organizations, and institutional arrangement. So here the five family member of a GIS is hardware, software, data, people, and methodology. These 5 are, it is the cyclic process, and that process is known as that is a GIS. And what this function, what this family perform, what is the function of this family? Collection, storing, analyzing, disseminating the information about areas of the earth. Okay, so we have to collect, just like I told you the examples of SNIT. So like this, you have to collect the data, You have to store in a proper format. Normally the Excel file, previously it was used only DBA format, but now XLX, Excel, Excel SX format is also there, that is higher than 97 2003 version. So which can be directly open or loaded in a ArcGIS software. This is given by some Duke and other person in 1989. Then another person, Taos, is given the definition. It is the computer-based information system for collection, management, manipulation, analysis, presentation, and dissemination of geospatially referenced data. Here, whatever our data is there, it must be related with the Earth. Earth means atmosphere, on the Earth, inside the Earth. Earth, without Earth, you cannot say that the details of the bank account of Mr. X or Mr. Y. No, it's not like that. But for the rainfall in a South Gujarat or rainfall in a Dang district, okay, or the heat in a Patna or Delhi, okay, that can be there, or snowfall in Kashmir, Himachal. So that event you can analyze. There is one more definition, that is in terms of mathematics. It is the same thing is there, but wordings are of mathematics. Measure the aspects of geographic phenomenon and processes. Geographic, Earth is there. Phenomenon and processes, rainfall, runoff, air pollution, traffic, emission of SOx, NOx from the vehicle. Whatever the phenomenon, what are the processes there. Represent this measurement in the form of computer database. So it is what? Nothing but it is the converted into Excel file, and that Excel file is added, uploaded in a GIS software. Operate these representations to produce more measurement. Now on the PC, by using this Excel file, suppose say I want to prepare the topographical map of a Surat city, and I have all the readings of total station reading is there. I am just talking about 2007 and 8 from corporation. I took the data. So that survey was done by the total station, and there were 36,000 where they're covering entire Surat and their spot height. So from that I can prepare the topography. Whatever the topography I'm preparing here using GIS, that is nothing but it is known as a DEM. It is the advanced or digitized version of contour map. So that is there, produce more measurement and to discover new relationship. So from this 36,000 points, using GIS software and the tools, I can prepare a map which is known as a digital elevation model and which can give you the idea of topography. Contour map also gives, but contour map you cannot add in GIS software. Cannot add means it is not useful. You have to digitize contour map and convert it into DEM. That is the main requirement of GIS. And transform this representation to confirm other framework of entities and relationship. Means looking to this image or results, you can take the decision and develop new entities. This is in terms of mathematics. So now the key components or the family members, normally it is given by the key components: hardware, software, data, liveware, okay, and methodology. Here methodology just I have not written, but hardware. Hardware means nothing but it is your desktop, laptop, okay, that is there. So without that you cannot further progress, because in the definition itself it is written that it is a computer-based mapping tool. Okay, that is written computer-based mapping tool. So it is a desktop PC and laptop is required invariably. Then software. So here software, there are two types of software. One for your operating system of your PC or laptop, and another one is GIS software. Okay. GIS database, just I will take little later on. Liveware means the people, the students, their team, those who are working with the problem or the project. So there may be two teams. One team is focusing on only on GIS aspects and GIS software, and another team is working on only on that engineering aspects. Okay, so that they will supply their data as per requirement of the first team, or sometimes the persons have a knowledge of both the technique, GIS technique also, and engineering software also. Say HACRAS is an engineering software, ArcGIS is a GIS software, and you can use both to solve the problem of flood. Okay, it is there. You must now ArcGIS is a very wide range of applicability. I also know there all the functions. Of course, few I know because I work myself for my research work. Methodology means you have to develop the method model for your problem. Say my problem is a Surat city is under flood in 2006. So if from the Ukai Dam, they are releasing 10 lakh water, then in the Surat city, how much area will be submerged, and after how much time when it starts from Ukai. Okay, in between Kakrapar, where is there? So that methodology modeling I have to means one has to develop. Here GIS database that is remaining. So database it is written that spatial data and spatial data or attributed data. So this data is much more important. It is the organization of hardware, software, network, data, people. Okay, and it is the cyclic process. Okay, hardware people. These are the software masters. This is the data, some procedure, methodology, and this is the group of the people they are discussing. Interpretation and other things are there. Now I will focus here in this data. Okay, but let me something different. Yes. Okay, here then after I will go to that. So hardware means it is a computer, CPU, other things are there. Storage device, pen drive, and so many things. Input device, keyboard, scanner, mouse, and output device that is nothing but printer, plotter, and other things are there. And communication and networking is internet connection of whatever you are taking. At present SUNIT, but I am using from the Vodafone connection. So that is a networking and it is coming under hardware. Software, two things: operating system, Windows, Linux, WinLin, Unix, anyone you can take. Normally we are taking Windows and we have that Microsoft Office software or Windows 8, 10, Windows 10 Pro, that systems are there in our PC laptop. Basic GIS software is used and very effective and widely used, that is developed by ESRI, Engineering, Science and Research Institute. Engineering, Science and Research Institute. So their software ArcGIS is much more popularly used by the person. When I was working as a scholar, I used ArcGIS 9.2. In our laboratory, we have 9.1, 9.1, 9. We have purchased 9.1, but then they have enhanced 9.3 during the warranty period. Now we have license version 10.5 with us. Okay. Then Intergraph, Geo, that is a Geo Media and other softwares are there. Autodesk, that is AutoCAD mapping. In AutoCAD software also, they have introduced the GIS component. Map Info, Bentley, PCI, Geomatica. Okay, these are the different GIS software. Plus, as per your problem, you have to take the engineering software also like Hackras, HGRS, Hack HMS, RiverCAD, whatever is your problem. Okay, you have to take the you have to combine the coupled with the engineering software to solve your problem. Okay, and data management system and language which just I have discussed. Yes, here where I left you the data, I will explain you little later on. But here, then after we will go for the three views. So GIS database, here this was spatial and related data. So very first, let me explain you what is the data. Okay, so data is nothing but it is the information about the event or phenomenon taking place related to Earth. Okay, so information means say flood. Flood is taking place in a Surat city. So what is the rate of flow? What is the rate of discharge from Ukai? What is the height of water at Ukai, at Kakrapar, and at Singanpur? Okay, it is coming in the way of Surat. That is in the way of a Tapi river. So this all the data we have to collect. So that information may be in terms of a tabular form, Excel file, or tabular form in a hard copy. We have the video, photograph, images, okay. So many things are there. So that is the data. Normally, the data when we are feeding it or uploading in a software, it must be of that matching with the software. Okay, so if you will put, suppose say you have a contour map hard copy available in your college or corporation, and they are giving you for the study of the Surat area. So if you will scan it, then it will not be doing the work. Just I will explain you this thing. So spatial data, attributed data is what? Spatial data, it means that that data has their location detail. Okay. Say Tapi College, location of Tapi College. Location means there is the address is there. It is in a Varasha Road. It is in the Kapodra and so and so and so and so. No. You select any one center point of center point of a Tapi College or its administrative building or its main entrance. You put their GPS and note down what is the latitude, longitude, and height. So that is your Tapi College location, and that is a spatial data. Now, in Tapi College, how many branches of engineering is there? How many laboratories are there? How many boy students are there? Girl students are there? Year-wise students detail, teacher detail. Out of that, how many teachers have PhD? So that all data related to Tapi College. So that all data is known as a attributed data. While location of Tapi College, that is some lat launch. Of course, for it will be 72 and 21. There is a difference in terms of some seconds. For Surat, it is 72 and 21. Okay, lat launch is there. So it will vary in that range, but it is in terms of either minutes or seconds. So that is spatial data and attributed data. So when we are collecting the data or when we are analyzing the flood problem, flood in a Surat city, when it is flowing in a river Tapi and when it is spilling over both the side, so we have to take the spatial data. Spatial data means we have to take the topography of Surat city, and that is nothing but it is a topographic map. But it must be in digital form, and that is known as a DEM, digital elevation model. That is one thing. Second thing is what is the flow of water at the 8th August 2006 at some time 6 p.m. or whatever the date, so that you have to take that data. So to solve this problem and to make the something like modeling or some mapping, you have to use the GIS software plus software related with the flood analysis. So HACRUS and ArcGIS you can use. We will not talk about HACRUS at today. So this is the data. So spatial data, non-spatial data, attributed data, aspatial data, all these are having the same meaning. Methodology, people already discussed that the persons may be having the knowledge of both GIS and his engineering problem, or only there is a one person is doing GIS and one person is knowing about the engineering problem. Okay. Okay, before this data model, yes, let me come. How this view of GIS. Okay, so GIS is having three views, means how it looks. Because when we are using the GIS tool, then how it looks. So it is a database. Database view means there is an Excel file, some description. Okay. Excel file means height of the water, hourly height of the water, discharge from Ukai, which is there in a tabular form. In a soft copy, it must be in a Excel form. That is a database. Okay. So this is the nothing but that database must be the geo database, and fundamentally GIS based structured database that describes the world in geographic terms. So whatever the data is there with you must have linking with the earth surface कि ये event earth surface पर कहाँ पे हो रहा है. Okay, like that flood is taking place in a Surat city in a river Tapi in 2006. So there is some data maybe in Excel form, release of water, quantity of water, and other things are there. Map. The GIS data, water you have, it is in terms of map. Suppose a map of Tapi College is having with you. You will scan it and you will get the soft copy of the Tapi College map, and now you can work on this. But normally when we are scanning, it must be in during the scanning, it must be of high resolutions, and just and you have to take the which type of format. Okay, because format is important. Normally we know JPG, bitmap, okay, JPG, BMP, PNG, that is known to us. But normally in a GIS we have to use TIFF, 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 IMG, .shp, like that different extensions are there. That is one thing. Second, there is an nmap view is there. Now model view means you have developed some model, some techniques. Of course here, just the things are map view, which I explain you. So there is a map is there. This is just GPS instrument, and this is the snapshot of ArcGIS window. You can see this, and in a map form means if you want to understand the phenomenon, either you can use the tabular form database, either you can have the map. Corporation has just produced the map of prima facie after the 2006 flood. Okay, so that is in a map view. And third is the model view. Okay, so you have to put some input, study area, or say, if I can say the flood inundation map, then flow of water and topography. Okay, that is important because topography means how the grounds undulations, which helps in flowing or further advancing of the water, plus land cover knowledge. Land cover knowledge means what type of surface is there on the earth, and accordingly the n value of n rugosity coefficient offered to that flow. So this is the model view is there. Okay, so these are the things, data, okay, methodology people, and now this is the data models, because here there are fundamentally two types of data models are there, vector and raster. Now I think the vector word must be known to you. Sorry. Vector word must be known to you. But raster word is maybe new for you, or you may be knowing. Now, when we are presenting our map or our work in a picture form in a GIS software, so it may be either considered or treated as a vector form, or it is treated as a raster form. So vector form, okay, just I will give you the example. When you will go to some hill stations, okay, and normally now we have a habit to take the selfie photograph and normal photograph by the mobile, okay, or somebody has much more inclination towards photography, then they are having the zoom lens camera also there. So you are taking the photographs, and then you are taking the printout either from the studio or at your home, whatever is your choice. So that developed product is known as a raster product. Okay, suppose say you are going to some hill station, and you have clicked your partner's photo, and that photograph you put it, you developed it in a glossy or matte sheet. That is the raster. But when you are going to the hill station, and at the same time normally you have experience that persons are that poor persons or artists, maybe poor, may not be poor, but the artist, they are saying that साहब बैठ जाइए हम आपका sketch आधे घंटे में बना देते हैं. So then you are whatever, you are just sitting and that fellow is making your sketch, and it is looks like you, means because that fellow is artist. So that picture developed is a vector. Okay, so vector model is using only point, line and polygon mode. Point mode, polyline mode or polygon mode. Okay, so that is a vector, and raster is composite of a continuous feature, and it is divided into the pixel format. Now if you will see here, so this is my real world where there is some forest area, grass is there, this is some small stream with the lake, and this is the grass area or something, and then other thing, this we can say is a marshy land or grassland. So if I will draw it this boundary, okay, like this here. This is my vector model because this is the polygon I have drawn and I have given the name marshy land. I have drawn this stream by the line that is a polyline and I make this circle, not circle, but bounding polygon is a lake, and then this is the boundary of the forest, and then remaining portion is a grassland. This is my vector, but this same area I will divide it into the cell size known as a pixel, picture element, and this size is say 1 centimeter by 1 centimeter or 5 by 5 centimeter or 10 by 10 centimeter. And in one box, one cell, what is there? Marsh is there. Marshy land. In a second box, marshy. Third marshy, fourth marshy, and then grassland. Here first marshy, second is a stream, third is marshy, fourth is marshy, and so on. And here this is the stream, and then here there is a blue, that is a reservoir, or it is a small lake. So what is this? The cell I have filled up with the feature. So as my cell is larger, efficiency is less, and cell size is lower, efficiency is more. So that is the raster. Okay. So just raster versus vector. So raster is composed of pixels while vector is composed of path, line. Raster graphic such as a GIF file, JPG file, and array of pixels of various colors, which together form an image. And vector graphics is either in a .shp format, .dps file, okay, and it consists of point, polyline, and polygon mode. So here, whatever the work we are doing, we are digitizing in a GIS software, that all the work will be stored as a vector layer. Okay, now the things, just 1 minute. So here, this is the theme, layer wise structure. Okay, Pragna madam. Hello.
जी sir.
Can I take 5 minutes more?
Yes sir, definitely sir. You can take 5 minutes.
No, because actually there is something just wasting of time. And after this, is there any session or this is last?
No sir, this is last session of today.
Okay, but I will not take much more.
No problem,
So,
sir.
so don't worry, participants. Normally, what happens? Be- because sometimes that happens. But actually, the interesting portion will come now. Now means actually that we are not doing, but just I will show you a little bit demo. Here, the theme-wise structure. The GIS is a theme-wise structure. Okay, theme means there are different themes. Say Tapi College campus is there. In this campus, Tapi College, what is the road network? In Tapi College campus, what are the buildings? In Tapi College campus, electric light poles are there, which is there used for night purpose. Okay, so I have the map of a Tapi College, and it is in a say soft copy. Whether you have scanned it or it is prepared in AutoCAD, and now that map is given to the students team. 3 teams you can give that map soft copy. Pragna madam will give that soft copy to the student, and one students what will say, in that map roads are also there, buildings are also there, and light poles are also there. So what the madam will say that one team you just digitize the road. Digitize means you prepare the layer of road looking to the I mean using that Tapi College map in a GIS software. Second team C will say you just digitize the buildings in a Tapi College. So you prepare building layer. And the third team C will say you just mark the electric pole. Suppose say 60 poles are there in a campus. Okay, so they have to prepare the pole layer. So it is a layer wise structure. Okay, so if you will see here, this is really say, suppose just take it granted, this is a Tapi College campus where this is the streets, green ones are road, red ones are buildings, and say these are the light pole or tree in a campus. Okay, so it is a layer wise structure. When so that layers depends on your theme, which themes are there. So here when you are using this there is another thing, same layer is there. When you are using the work on GIS, you have to use the decide the theme, and accordingly the theme you have to make the layer. Okay, but here the things, whatever the map which is scanned, or suppose say image of Tapi College, if photograph developed from the aircraft, or your satellite image you have taken for a Surat city and you have cropped the Tapi College, and that you are giving to your students, that is the raster format. But the three teams of students are making building layer, road layer, and electric pole layer is a vector model. So their extension is .shp. Now how to do that thing? It is in ArcGIS software, but that we are not touching. Okay, we are just coming to the software directly. Now GIS workflow, these are the different layers. What is the GIS can do? Okay, and this thing just I am skipping. And what are the advantages? That is reduction in data redundancy, data integration, maintaining data consistency, capability of data updating, capability of data storage and retrieval, processing and modeling, automated mapping. Previously, only the persons, draftsmen, cartographers, they are able to prepare the graph, and they have, if they have good writing, they will write down the titling and other details. But now with the GIS software, we can take much more. Everybody can prepare the graph because we need not to do means actual that drawing work. Of course, data, Excel file, map that we have to scan, we have to upload, and different tools we have to use. But exact drawing we need not to do. We have to just give that data, and then after you take print out. So everybody can make, suppose in Tapi College campus is there, and if that map is given to some draftsman, he will just make on a tracing paper all the roads. And if you have to make, you can also make, but it requires time and may not be perfect as perfection of a draftsman. But that can be done very easily in a software, GIS software. Okay, these are the application areas. As I initially told you, it is not the baby of civil engineer. Okay, it is a tools, it has applications, so many applications in civil engineering area. Okay, environment, water, transport, okay, urban planning, and other things are also there. Okay, so and it is used in flood mapping, hydrographic modeling, disaster management, hazard waste management, environmental engineering, geotechnical engineering, okay, and so many things are there. Now just I will tell you, if just I will show you ArcGIS software. That is how to use. Okay, so we must have the image of the area. Like I told you Tapi College image. Say I have Surat image. I have so many images of Surat cities there, but just for the prima facie, I downloaded from the Google Earth. Okay, digital elevation model to study area. There is a SRTM digital elevation model is there. LULC map of the study area and geographical location of the area, that is nothing but latitude longitude. Okay, so here just Surat image, SRTM data. So these two are the raster, and soil area and location of borehole and study area, these two are a vector. Okay, here now this thing you see, this is a snapshot of ArcGIS software. Just I will stopping this sharing and I will opening, already it is opened ArcGIS window. Okay, are you able to see this ArcGIS window, please?
Yes, sir.
Okay, okay, fine. So here okay, so here there are, you can see here there are 4 layers are there: borehole, soil area, SRTM, and Surat image. Now you can, this is a layer wise structure, you can make it of. Okay, so now there is a nothing is there. So initially from this you have to upload the data, that is in the form of either Excel file or in the form of a raster or image or something. So I have added first this Surat image. Now this is Surat city, river Tapi, and SVLIT is somewhere here. And here wherever you will put the cursor, so here you see it will give you the lateral launch. Okay. So when you will get the raw image, you have to georeference it. But now from USGS, Bhuvan and other things, you can download the georeference image also. So this is a raster. Okay, this is a raster from Google Earth. I downloaded. Then I downloaded SRTM DM. This is what this DM is, nothing but this is the topographical map. Okay, somehow here that tools is not available here in my, so means it is not loaded, that's tools. But here if you take the section, you will get the topography. This is the river Tapi, and the higher portion is the darker, this is the highest portion, and the white portion or the sky blue portion is a lowest portion. And you can take the topography, you can take, and this you see it is overlapping on, because this is also georeference and this is also raster. Okay, just I am removing this. Removing means I am switching off the layer. Now if I want to digitize, okay, this river Tapi, then here I have to use the digitize tool. Okay, and then after I have to make that digitize tool, means which type of feature you are going to digitize, whether point, line, or area. So whatever, suppose if I want to digitize here Tapi river, and then after if I will make this layer off, so my river is digitized, but I have to create first blank layer, that is a vector layer, that is .shp format, and then you have to start digitization. So here this is the soil area, this is the borehole, so these are the borehole, just randomly I put that this is some interest of soil area, this is polygon, this is point mode. Okay. So here there is a tool is not activated here, but there is a plus sign will be there, and that plus sign you have to click here. Okay. Just like if you will click here. Okay, if you this panning symbol will not be there, but plus symbol is there, and you will click here, then it is going to be digitized. Digitized means what? If you will click here, you are giving identity to that point in terms of let launch. So if here it is there, you can see at the down, it is 73 degree, whatever is there here. On this I put my cursor, it is 74, 40, 72, 47, 51, 306 east and 21, 10, 39.227 north. Okay. So if I am clicking here, so this point has its absolute location I have assigned. That is nothing but digitization. Same way here, I use the digitization tool and I made this area randomly. That this area is useful for me for study of the soil. And same way 1, 2, 3, 4, 5, I put the point mode and I digitized, because in this junction I want to know the borehole, or borehole already exists. Now if I will remove the image, then this two layer, borehole layer and soil area layer, it is here. If I will switch off this, only borehole is there. If I will switch off borehole, then only soil area is there. Like this, team 1 has done road, team 2 has done building, and team 3 has done light pole. Okay. So like this, here you can switch on. You, but how you put this? यहाँ पर बोरहोल होना चाहिए, या तो यहाँ पर बोरहोल है. That is from the image. Okay, here I put it randomly, but from that you can do this thing. So you can put here by clicking river Tapi also, and if then after you will switch off this layer, you will get here river Tapi also. Okay, so this is the GIS software, and so many work is there. Here if you will open this tool, this is ARC toolbox. So okay, so here you can have 3D analysis, cartography, conversion, data management. Number of tools and number of facilities are there. Okay, and lastly I will tell you, when you are using GIS data and you are transferring data from your PC to your laptop, or laptop to PC, office to home, or home to office via pen drive, only use this ARC catalog. Okay. Sorry, it is okay. Only use this ARC catalog, because here if you will see this soil area file, simple window browser you don't use. What happened? Window browser if you will use, then it will not take the entire file. Here say SRTM DEM, you will find only SRTM DEM, but there are other associate file srtm.aux, srtm.rrd, srtm.falana. So many supporting files are there, which you are not able to take, or even which you are not able to identify. But if you will use ARC catalog, and if you will pick up all that 4 or 5 files, supporting file will display as a one single file, and you can take it as a single file. Okay, otherwise what happened? Simple Explorer, if you will copy the data, then you will not open your file or layer in home or house. Okay, तो लगेगा अभी तो मैंने पूरा काम किया था, वो सब कहाँ गया? So when you are using ARC, I mean GIS data transfer, only use the ARC catalog. Okay, so here just I am once again stopping my sharing, and that my last slide of this PPT, okay, which I am sharing here with you. And with this, okay, I am ending the session. So this is the GIS, and remote sensing is a very fundamental things. Actually, in this GIS software, how to operate image, and there's so many things are there. But as per your interest and your inclination, you can go further. Okay. So thank you all for patience hearing. Okay. So Pragna madam, over to you.
Yes, sir. Yes, sir. Ravi, sir.
Uh,
I am stopping the presentation.
okay, okay. I request to all the participants, if you have any questions, then write into chat box so we can ask to our respected expert.
Uh, Pragna madam,
Huh?
Yes, sir.
hello.
Hello.
Ji, sir.
Whatever their questions are there, you just collect it, because actually at 4 o'clock I have to go to
Okay,
some
sir.
Okay,
Okay, sir.
okay,
meeting.
sir.
No
But anyway,
problem. We are
so
going to end
whatever
up this session, sir.
whatever their
Sir.
and no, you just collect their questions. I am leaving this. You collect questions and you just send it to me. Then I will discuss, or with them also, because, or I will just give the answer also and I give it to you. Okay, Pragna madam.
Yes, sir. Yes, sir. Definitely, sir. Sir,
Okay.
please wait for 2 minutes only.
Okay. Thank you
Yes,
so much, sir.
sure.
For
Why not?
okay. Thank you so much, sir, for your wonderful session. A big thank you to Dr. Agnihotri, sir, for efforts toward fundamental of GIS and remote sensing and its application to civil engineering. Really, sir, I thankful to you for such a nice expert lecture. Very good presentation, and we got good knowledge from this presentation. Thank you, sir.
Thank you,
Okay.
sir. Thank you for this informative speech. I really thankful to you, sir, and for
Okay,
such a nice expert lecture. You have given a very realistic example in your presentation. I must mention our deep sense of appreciation for sir for his explanation of application of GIS and remote sensing. A special thanks for being here, sir. Thank you so much, sir. Now, I would like to
Okay.
thank sir, you can leave now.
So thank you, Pragna madam. Thank you, Ravi ji, and
Yes,
thank
sir.
you all the participants.
Welcome, sir.
And only the things that this is such a tool. Without this, now research is not possible. Okay, like that, without mobile now, if mobile के battery गए तो बोले अब कुछ नहीं हो सके. That's why this is also a very good tool for helping and to make your research speedy. All the best to all of you. Okay, thank you, madam and Ravi ji, once again. Thank you.
Thank you, sir.
Thank you, sir.
Dear participants, please switch on your camera. We want to take a screenshot. Dear participants, please switch on your camera. ले लो. Thank you, sir. Thank you very much, all of you. Hello. Thank you very much, all of you. We will meet up again at 10 a.m. tomorrow. Exactly 10 a.m. We will start our session. So please join on time. Dear participants, please do not share attendance link with others, because some responses are there. Some participants have not registered till, and we have some responses from outer side participants. So please don't share our attendance link to other. Thank you all.